Today we are going to discuss geometric sequences. So what is a geometric sequence? A geometric sequence is when you multiply or divide to go from term to term. So unlike an arithmetic sequence, you're adding or subtracting by a number. For a geometric sequence, you're multiplying or dividing to go from the term to term, okay? The common ratio is the ratio between the two terms. You can think of this as like the common difference of an arithmetic sequence, okay? So a way to find the ratio between the two terms, we're going to label that as R, okay? And you can find that by taking the next term and dividing it by the previous term. So that's why I put a sub 2 here. Okay, and I'll show you what that looks like as we do some problems. So let's determine whether the sequence is geometric. If yes, let's find the common ratio. If no, then we're going to state no. Okay, so on number one, we just gotta find, we gotta see if we're multiplying or dividing by a number to go from term to term. So I know 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. So yes, this is geometric. The common ratio, R, was 2. Okay? I apologize, that was my dog. Okay. Number 2. Let's see here. 4 times 2 is 8. 8 times 2 is not 20. Another way to check that, guys, is to remember you're going to take the previous term, so 8, and I'm going to divide that by the 4. That's how I got the 2. And then I can do 20 divided by 8. That's 2.5. 60 divided by 20 is 3. So clearly these are not the same numbers. So this is not geometric. Okay. And then on number 3, I'm not quite sure what I have to multiply that by, so I'm going to check it. I'm going to do 8 divided by 3.2 in my calculator. I get 2.5. 20 divided by 8. I got 2.5 again. 50 divided by 20. See how I'm taking the next term and dividing it by the previous term? I got 2.5. So this is a geometric sequence because I am multiplying each of these by 2.5. That's my common ratio. Okay? All right, number 4. It says write a geometric sequence with a ratio of -1/4 and it must have at least 4 terms. So answers can vary here. I'm just going to pick a number. I don't know, 128. Okay. And if my common ratio is -1/4, that means I'm going to do 128 times -1/4. So I get -32. It looks like I need 4 terms, so I have 2 terms right now. So now I'm going to do -32 times -1/4. Again, I get 8. 8 times -1/4. I get -2. So I have 4 terms, I'm good. Again, your answers can vary here, all right? It says write any geometric sequence, okay? As long as you're multiplying each of these by -1/4 or dividing it by -4, okay, then that's how you get the next 4 terms. All right, let's talk about the geometric sequence formula, okay? So just like the arithmetic sequence, there is a geometric sequence formula. So the nth term of any geometric sequence can be used using the formula a sub n equals a sub 1 times r to the n minus 1 power. A sub 1 is the first term, like always. And r is the common ratio, like we have already discussed. And remember, n is just like whatever term you're looking for, like the term number, okay? So we are going to write a rule for each sequence and then find a sub 6. So let's find, so when it says find a rule, write a rule, it means like write the equation, okay? So let's go ahead and figure out what that is. So let's see here. It's going to be a sub n equals my first term, which is 1, times r. Looks like these are all just being multiplied by 5. Yeah. So r equals 5. So I'm going to plug in a 5 right there. And then it would be n minus 1. So when it says write a rule, that's what it's asking for. Okay? Now it says go find a sub 6. So I'm going to box that off. So a sub 6 equals 1 times 5, 6 minus 1, because that's the term number we're looking for. So in my calculator, I'm going to do 1 times 5 to the power of 6 minus 1. 3,125. Okay? Easy enough. All right, number 5. We got to find a rule here. So a sub n equals negative 3,200 times, I've got to find my common ratio. I'm not sure about this one, so I'm going to do 800 divided by negative 3,200 in my calculator. Let's see here. That's negative 1/4, so this is multiplied by negative 1/4. Let's see if that occurs here. So negative 200 divided by 800. Got negative 1/4 again. That's promising. Let's do 50 divided by negative 200. Got negative 1/4 again. Perfect. So I'm going to plug in a negative 1/4 for r, because that's what it equaled. Then n minus 1. So that's my rule. Like that's the formula to solve this sequence. And then I want a sub 6, because that's what the direction said. So negative 3,200 times negative 1/4 to the power of 6 minus 1. Let's type that in. Negative 3,200. Make sure you use the negative sign, not the minus sign. Parentheses, and again, we're using the negative sign. I don't know why I hit that button. There we go. 1/4 to the power of 6 minus 1. 25/8. Let your teacher know if you are having trouble just typing this into your calculator, okay? On the back, we are going to use the information given to find the indicated value. I'm gonna real quick rewrite that formula down so I can refer back to it for you guys. Sorry guys, my dog is making noises. Okay, so use the information to find the indicated value here. So we have a sub 1, r, we need to find a sub 8. So we're finding a sub n, which is really just a sub 8. A sub 1 was 7, r is 4, n is 8, because that's what it's in place of. All right, that was easy peasy. Let's type her in. 7, 4 to the power of 8 minus 1. Guys, remember in your calculator, your parentheses are your best friend, so make sure you use those parentheses. So I got a sub 8 equals 114,688. All right, number 7. A sub 5, r, find a sub 1. Ooh, so we're kind of working backwards on this one, it looks like. So a sub 5 is negative 68. So I'm going to replace that with a sub n there. Equals, we want to find a sub 1. I don't know what that guy is, so I'm going to put that there. Then I know that r is negative 0.5, so I'm going to keep that in for r. My n value is 5 because I used that for the negative 68. So I'm going to do 5 minus 1 up there. All right, so let's simplify the right side of this equal sign. So I have negative 68 equals a sub 1 times, in my calculator, I'm going to do parentheses negative 0.5 to the power of 5 minus 1 is 4. If you want to type in 5 minus 1, that's fine. So 0.0625. All right, and then that is being multiplied by a sub 1, so to get the a sub 1 by itself, I'm going to divide by it. So negative 68 divided by 0.0625. Negative 1,088. So that one we had to do like a little algebra to help find that. All right, number 8. A sub 1, a sub 4, find a sub 3. All right, so essentially we have to find a sub n, which is a sub 3. But in order to do that, I'm going to need r. I have a sub 1, but I don't have r. So we're going to have to do some math here with this information to find r first. So let's say that the a sub 4 is this a sub n right here. So that is equal to 4,459. My a sub 1 is 13. We don't know what r is. And my n value is 4 because that's the term number I was looking at. So 4 minus 1. All right. So we get 4,459 equals 13r to the third power here, because 4 minus 1 is 3. All right, to get r by itself, this 13 is being multiplied by it, so I'm going to divide by 13. So 4,459 divided by 13, got 343, sorry, equals r to the third power. And then remember, to get rid of something that's being cubed, we're going to take the cube root. We did this a while ago. So in your calculator, you can hit math. It's option number 4. 3, 4, 3. So I got r equals 7. Do not type in 3 square root of 343. That's a totally different answer. That's a big no-no. Do not do that, okay? Make sure you use the cube root function. All right, so now that I know what r is, I can use this formula to find a sub 3, if my pen works. So a sub 3 is going to equal a sub 1, which is 13. R was 7. N is 3 in this case, minus 1, and you can just plug that into your calculator all nice and beautifully. So 13 times 7 to the power of 3 minus 1. A sub 3 equals 637. Perfect. All right. One more problem here. All right. Brad dropped a bouncy ball from a height of 64 feet. After the second bounce, the ball reached a height of 36 feet. Write a rule to represent the height of the ball after each bounce. Then find the height after the fourth bounce. Okay, so Brad drops a ball from a height of 64. After the second bounce, so this 64 does not represent the first bounce. A sub 1 is going to represent the first bounce. This is the height that he's starting at. After the second bounce, the ball is at 36 feet. So that's where I'm putting that guy at. And we want to find the height after the fourth bounce. So a sub 3, a sub 4. Okay. So in order to figure this out, let's see here. Okay, we're gonna have to use this formula and work a little backwards here. We gotta find out what that common ratio is, right? So in order to do that, we have to pretend, so I'm gonna use a sub 2 since that's 36. I'm gonna plug that in, is equal to our a sub 1. I'm actually gonna say like this is our a sub 0. This is kind of like our starting spot, okay, like our initial. So I'm gonna plug the 64 in right there. We don't know R, and in this case, N is 2, but I'm not going to use a 1 here because that's when we use a sub 1. I'm actually going to use a 0 because this is like the initial height, okay? So this is a little tricky here. Only we would have to worry about this in an application setting, okay? If they give you a height, but we're really counting that our sequence is bounces, not like where we're starting at for the height, okay? So that's the tricky part there, okay? Because we're messing with the initial height. All right, so now this kind of looks like number 8 when we go to solve for R. So we have 36 equals 64, R to the second, because 2 minus 0 is 2. To get R by itself, I'm going to divide both sides by 64. 36 divided by 64. I got 9 over 16 in my calculator. Okay, and then to get rid of that squared, I'm going to square root both sides. So I'm going to take the square root of 9 over 16, which is really just the square root of 9 and then over the square root of 16, so 3/4. So that's my R value. All right, now you could just multiply each of these by 3/4, or if you want to use the formula, you can do a sub 4 equals a sub 1, which actually we are going to have to find. So I'd have to do 64 times 3/4, which is 48. So times 3/4, you get 48. So that's my a sub 1. R we said was 3/4. And then we want the 4th term, so n is 4 minus 1. Okay, so a sub 4, oops, equals, let's see here, 48 times 3/4 to the power of 4 minus 1. I got 81 over 4, but it says, what's the height after the 4th bounce? So on that 4th bounce, I'm actually going to change that to a decimal, and we get 20.25. That's kind of a pretty decimal, so it's fine. So 20.25, and what are units? Feet. So that is the height of the ball after the 4th bounce. That's it.